Welcome to a video on solving linear programming problems using Desmos. In this video, we're going to look at finding a minimum value on an unbounded region. Let's get started. As you're solving linear programming problems, it's good to remember the fundamental theorem of linear programming. This says if a feasible region is bounded, then the optimal solution for the objective function, meaning the maximum or minimum, will occur at one of the corners. If the feasible region is unbounded, then a maximum for the objective function does not exist. If a minimum exists, it will occur at one of the corners. Let's use Desmos to solve the following linear programming problem. We want to minimize the objective function c equals 4x plus 3y. Subject to the constraints, x plus y is greater than or equal to 5. 2x plus 3y is greater than or equal to 12, x is greater than or equal to 0, and y is greater than or equal to 0. Here are the steps on how to solve a linear programming problem using Desmos, and then we'll work our example together in Desmos. Start by using Desmos to draw the feasible region and locate the corners. Then enter the corners into a table in Desmos. Then evaluate the objective function at each corner point. To do this, use the last column of the table to insert the objective function, but you'll need to replace x and y with x1 and y1. All of the Desmos graphs in this video are linked in the video description. Let's go over to Desmos and enter our objective function and constraints on the left side. To open the Desmos graphing calculator, go to the website desmos.com, click on the button Graphing Calculator in the center of the screen. Or from the Math Tools menu, select Graphing Calculator. When the Desmos Graphing Calculator first opens, you will see a blank graph. Go over to the left-hand side and enter the objective function and the constraints into the cells on the left. As you can see, I've already added the objective function and the 4 constraints to the left side. Now we want to identify the feasible region. The feasible region is where all of these inequalities overlap. So I'm going to toggle the shaded area on for all 4 of the inequalities. Since we have 4 constraints, we're looking for where all 4 shaded areas overlap. Sometimes it's useful to go over to the upper right corner and use the zoom in and out keys to zoom out so you can see where these overlap. You can also use the mouse to scroll out. If you have a hard time locating the overlapping area, try turning them all off and then slowly add them one by one. So we want where y is greater than or equal to 0, that's the top half of the plane. Where x is greater than or equal to 0, that's the right half. Now we're confined to the first quadrant, since that's the only area where x and y are both greater than or equal to 0. Adding the inequality 2x plus 3y greater than or equal to 12 adds this green line, and it's shaded above the green line. So now we know that it's going to be above this green line in the first quadrant. Let's add our last inequality, x plus y is greater than or equal to 5. Once again, because that's greater than or equal to, we're shading above that line. So it looks like we have an unbounded region in the first quadrant. Let's click on the wrench in the upper right corner to set the graph settings. Let's choose x values that range between -2 and 10, and y values that also range between -2 and 10. It looks like one of our boundaries is the y-axis up to this point 0,5. Then from 0,5 it continues on to the point 3,2, down to the point 6,0, and then using the x-axis after that as its last boundary. So we only have 3 corner points. Since this area is unbounded, it's just going to keep stretching off to infinity, going up to the upper right corner. Let's go over to the left side and enter our corners into one of the cells. Let's add a table by clicking on the Add Item in the upper left side and choosing Table. That was 0, 5, 3, 2, and 6, 0. And I'm just using Tab to move between the cells of my table. Now, just to emphasize where the feasible region is, I usually like to draw a polygon around the feasible region. This step is really not necessary, and you can skip it if you want. Since this feasible region is unbounded, if I want to draw a polygon around the outer edges, I have to add a few points that aren't exactly corners to the feasible region. To do this, I'll go up to the gear at the top and I'll make a copy of my table. And I don't want to confuse this with the corner, so I'm going to rename this as X2 and Y2. And now I'm just going to add 3 additional points around the corners of this graph. So I'm going to add one at 10, 0, 10, 10, and 0, 10. So that was 10, 0, 10, 10, and 0, 10. Now I can type the command polygon X2, Y2, and Desmos will connect all of those additional points, including our 3 corners. And in black here, you're seeing the feasible region, or essentially what the idea of the feasible region is. We have a boundary on the y-axis, these 2 diagonal lines, and then the x-axis. This region is unbounded. It does keep stretching on up to the right, but I usually like to draw a polygon around it because it is difficult to see where the actual feasible region is when all of those shaded areas are overlapping. So feel free to skip that step if you want. Now that we've drawn our feasible region and we've identified the corners, we know that since this region is unbounded, there will not be a maximum value. However, we're only asked to find a minimum value for this problem. To find the minimum value, the fundamental theorem of linear programming says it will occur at a corner for an unbounded region. Let's go back to our first table that contained the 3 corners. And in that third cell, enter the objective function, but instead of using x and y, use x1 and y1. So I'm going to enter 4x1 plus 3y1. Now Desmos has evaluated the objective function at each of our 3 corners. We're looking for the minimum value, so I'm looking for the smallest of these 3 values, which looks like it is 15. So our minimum value is 15, and it occurs when x is 0 and y is 5. To summarize, we used Desmos to solve the linear programming problem, where we wanted to minimize the function c equals 4x plus 3y, subject to 4 constraints. We used Desmos to draw the feasible region. We observed that the feasible region was unbounded. This means that no maximum value was going to occur, but if there was going to be a minimum value, it would occur at one of the 3 corners. We evaluated the objective function at the 3 corners to find our solution. Our solution was the minimum value of the objective function was 15, and that minimum occurs when x is 0 and y is 5. That's it for this video. Thanks for watching.